On December 25, 2010, astronomers observed one of the most unusual and longest gamma-ray bursts ever recorded. Known as GRB 101225A, or the Christmas burst, this extraordinary event puzzled scientists for its unprecedented 28-minute duration, far exceeding typical gamma-ray bursts, which last mere seconds to minutes. Gamma-ray bursts are among the most powerful explosions in the universe, releasing more energy in seconds than our Sun emits over its entire lifetime. They are usually classified into two types: short bursts, weak emerging neutron stars, and long bursts, caused by the collapse of massive stars. But GRB 101225A didn't fit neatly into either category, sparking debates about its origin. Detected by NASA Swift Observatory, GRB 101225A's light curves and spectrum showed an unusual pattern. Its exceptionally long duration suggested it wasn't just a typical stellar collapse. Two main theories emerged to explain this cosmic phenomenon. The first theory proposed that a neutron star collided with a dense helium-rich star, triggering the prolonged explosion. Such a rare event could produce the observed energy in extended gamma-ray emissions. The second theory suggested GRB 101225A was caused by a star being torn apart by a neutron star or black hole in a nearby galaxy. This violent disruption could also account for the long-lasting burst. As the gamma rays faded, astronomers tracked its afterglow in optical and X-ray wavelengths, gathering critical clues. GRB 101225A not only expanded our understanding of gamma-ray bursts but also challenged scientists to rethink how such cosmic events occur. The Christmas burst remains a cosmic mystery, a reminder of the universe's vastness and the surprises it holds. Whether caused by colliding stars or celestial disruptions, GRB 101225A exemplifies the power and unpredictability of the cosmos. If you enjoyed this journey into the wonders of space, don't forget to like, share, and subscribe for more cosmic explorations. Let's unravel the universe, one mystery at a time.